All right, class, let's work through a couple problems from a textbook that have to do with a one sample t-test. This first problem comes from page 395, problem 12.40. It reads, companies that sell groceries over the internet are called e-grocers. Customers enter their orders, pay by credit card, and receive delivery by truck. A potential e-grocer analyzed the market and determined that to be profitable, the average order would have to exceed $85. To determine whether an e-grocer would be profitable in one large city, she offered the service and recorded the size of the order for a random sample of customers. And then the question says, can we infer from these data that an e-grocer will be profitable in this city? All right, so let's walk through the 5 steps that we talked about in our notes. So remember, step one was to form the hypotheses. Right, so we have some sort of null hypothesis and alternative hypothesis. So in this case, it's not straightforward what the null hypothesis is. There's no status quo. There is no sort of nothing interesting going on here. But there is we're told what we want to try to prove. And remember, what we want to try to prove belongs in the alternative hypothesis. So in this type of problem, we just sort of start there. Right. So in this problem, we want to find the average, so mu, this is my best attempt at mu is greater than or equal, greater than $85. Right, we want to show that it's greater than if it's greater than $85, then we're going to be profitable. So that's the alternative. Remember, the burden of proof is on the alternative, and so that whatever it is we want to try to prove belongs there. So the null hypothesis then just must be less than or equal to 85. All right. So we know this is a one-tail test, and it's going to be the right tail. Okay, great. So that's step one. Step two is go collect the data and calculate your test statistics and some other things. So we have the data over here. Here's our raw data. And we need to find a few things, right? We've got to find X bar. We've got to find our sample standard deviation, S. We're going to need to know N. And then we're going to need, at the end of the day, we're going to find a T statistic, right? Because we're doing means here. So X bar is just equals average. All right, so here's our data. Control Shift down, hit Enter. So on average, we have 89.26. All right, remember, we're trying to prove that it's greater than 85. So far, we're looking okay. But not necessarily, right? Not necessarily, because sometimes it's greater than 85 and sometimes it's less. Remember, this is just an average. So let's find the standard deviation equals standard dev. So we could do standard dev.s or just standard dev. Excuse me. Standard dev, let's do the standard deviation. Okay. Hit enter. So, oh wow, so we have a pretty big standard deviation of 17. All right, so that would definitely get us on either side of 85. All right, with even just one standard deviation gets us way over there. And that's just a count. I think the problem says how big it is. I can't remember though. 85. Yep. All right, and then remember to calculate a t, we have to do it's something like x bar minus mu divided by the standard error, which is s divided by the square root of n. Right? So something like x bar minus mu divided by this s divided by the square root of n. Right, which is really the standard error. So let's actually just do that. Standard error. It equals s divided by the square root of n. Yep, that's what I want. Uh-oh, something didn't work. It should be 10. There we go. S divided by the square root of 10. So there's our standard error, 1.87. All right. And so for our t distribution then, is for our numerator, we're going to say x bar minus mu. What is mu in this case? Well, we can look up here at mu of our null hypothesis is 85. So that's what we're going to use. We expected it, we're trying to prove that it's greater than 85. So that's our mu is 85. So there we go. Divided by our standard error. 2.27. So what do we think about that t? That's actually a fairly big t. I mean, it's not huge, right? But it's pretty big. All right, so that's step 2. Step 3 then is to set alpha, and it doesn't say anywhere in the problem except for that earlier on in the book it says just use a 5% significance level for all of these problems. So we're just going to use 0.05. All right, and then step 4 is to find a p-value. All right, find p-value. So how do we do this? Well, p-value for this is a right tail test. Right, one tail, right tail. So we just use this equals t.dist.rt. T.dist.rt returns the right tail student t distribution. That's exactly what I want. When it says x here, that's really what we need to put in for t. So there's our t right there. We went and calculated it. And the degrees of freedom, remember, that's n minus 1. So our n is right there, n minus 1. And that's it. Oh, there we go. P-value 0.012. All right, so what do we say now? Well, step 5, we have to make conclusions. And we say, well, since the p-value is lower than alpha, we reject the null and say that the average price, the average, what is it called? The average sales will be greater than $85. Great. So that's it. Those are the 5 steps. So the reason we can say that, remember, the null hypothesis, what we're trying to prove is it's greater than 85. So we have to put in the null hypothesis that it's less than or equal to. Right? So nowhere in the problem did it say it's always been 85. No. But we're trying to prove 85. So in this case, we just put this guy in the alternative hypothesis. The null then must be, again, the opposite of that. The equal sign belongs in the null hypothesis. We have enough evidence to reject the null hypothesis from the p-value, and so that we then say, well, the alternative then there's plenty of evidence for the alternative. And it makes sense, right? So we have our average was 89. Well, that's greater than 85. And our standard error was actually, got shrunk down pretty small because we had a pretty big n, right? So even though the standard deviation was big, we had a pretty big sample size, so our standard error got small. In fact, it was 89 is 2.27 standard errors away from 85, right? So it's pretty far out there, right? So if it was closer to 85, like maybe it was like 85.5 or something, right? So if this x bar, we could actually change it. What if this x bar was 85.5? So now our t is only 0.26, right? Really small t, and then look what happens. Oh, now we have a really big p-value, 0.39. So because in this case, if this were the case, if we had a really big p-value, then we say, well, there's not enough evidence to say that the null hypothesis is wrong, right? Because our sample only came at 85.5. That's not that big, that much bigger than 85. But I'm going to say Control Z, undo. Since our actual sample was 89, that really is statistically significantly bigger than 85. That's what we can say from this. All right, let's do another one. So 12.38. Let's see. 12.38 says, because of the enormity of the viewing audience, firms that advertise during the Super Bowl create special commercials that tend to be quite entertaining. 30-second commercials cost $2.3 million during the 2001 Super Bowl. A random sample of people who watched the game was asked how many commercials they watched in their entirety. Do these data allow us to infer that the mean number of commercials watched is greater than 15? All right, so this data then is a bunch of samples, right? The people were surveyed and asked, how many commercials do you watch? And they told them, right? And for whatever reason, the network, television, whatever, says that, well, we need to see if they watch at least 15, more than 15. So let's work for the 5 steps again. So step 1, remember the null and alternative hypothesis. So remember, in this case, it's actually very similar to the last one. There is no null hypothesis blatantly said in the problem, right? And in fact, this is typically how things work. Right, so sometimes it's the case where there's clearly this is the null hypothesis, but most of the time someone comes to you and says, well, look, I want to show, in this case, that people watch at least 15 commercials. 15, watch more than 15 commercials. What does it say? It's greater than 15 commercials. But whatever it is you want to try to prove, that's what belongs in the alternative hypothesis. So in this case, mu is greater than 15. And so in the null hypothesis, must be mu is less than or equal to 15. Right? So that's it. Right? If whatever we want to prove, that belongs to the alternative hypothesis. Again, this is one tail, right? And it's a right tail test. So it's going to be very similar to the last one we did. Right tail test. Okay, let's do step 2. Then is to collect some data. We already have that. And then formulate our test statistic. So again, we got to have the x bar. We got to have s. Oops. S. We got to have n. We'll find the standard error. And then we'll find t. Those are the things we're going to find. So remember, x bar is equals average. 15.26. See, that doesn't seem a whole lot bigger than 15, so this might be a different story. Standard deviation equals standard dev. I can use standard dev.s, but not standard dev.p. That will give me the wrong answer. Okay. And that's just a count, or we can read the problem and see how many were there. 116. Actually, the problem doesn't even tell us. So 116, okay. Remember the standard error then is just s divided by the square root of n. Okay. Uh-oh, I did this last time too. Equals s divided by the square root of n. There we go. 0.53. All right, so I'm gonna already eyeball this and say, you know, we're gonna assume that the mean is 15. And 15.26, I can already see this is not even one standard deviation away, right? That's what we got to find out next, because or standard error, because our standard error is about a little over a half, and we're not even a half away from 15. So I can tell already that we probably will not have enough evidence to reject the null hypothesis. But let's keep working through it. So to find the t, we have x bar minus mu, and what's my mu in this case? My mu is 15. Right, because that comes from my null hypothesis. Okay, divided by my standard error. There he is. Yep. So it's just barely a half a standard deviation away. Not very far at all. Is that right? Yep. Okay. Okay, great. So that's step 2. Now step 3 is to set alpha, and again, in these homework problems, we always set alpha to equal to 0.05. In the book, tells us to do this earlier on. Step 4 then is to find a p-value. In this case, it's a right tail test, so t.dist.rt for right tail. X, really what it needs is a t there. We already calculated the t. And degrees of freedom is n minus 1. All right, are we ready? Dun, 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 dun. So that's a pretty big p-value, 0.30. That's a big one, right? And so step 5, we make conclusions. Step 5, we say, well, since the p-value is larger than alpha, we do not have evidence to reject the null hypothesis, so we can't say that that the average viewer watches more than 15 commercials. Great, so that's it. All right, so hopefully that was helpful. Let's actually sort of play around with this problem. What happens if instead of a right tail test, let's not worry about the context of the problem, but we wanted to make this a left tail test? What would this look like? Well, instead it would look something like, let's just rewrite it over here. It would say something like mu is less than 15. All right, we wanted to prove that mu is less than 15, and we put it there. And then the null hypothesis would then be mu is greater than or equal to 15. Okay, so that would be a right tail test, right? Or sorry, left tail. Left tail. So t would still be the same. Everything would be the same except for all the way down to the p-value stuff, right? So let's come down here and find the p-value for a left tail test. So we say equal t.dist, not t.dist.rt, just t.dist. And in this case, we use our same t. Degrees of freedom is n minus 1, n minus 1. And then in this case, it wants, again, just like, remember the norm dist? We always had to put a 1 or a 0 in there, or a true or a false. We always put true or 1. 1 is the same as true. We want a cumulative distribution, right? We want something that's all the way up to a certain point. Left. Okay. There we go. Hit enter. So also very big, right? Very unlikely. All right, so let's do one more. What happens if we had a two-tail test? So that would be something like mu, and I don't know how to do this in Excel, but does not equal 15. And then here it would be mu equals 15. So this is a two-tail test. Again, everything would be the same as far as our x bar t would be the same, alpha would be the same. The only thing that would be different is a p value. And so in this case, we say t.dist.2t, two-tail. Right, and then again, x, in this case, x is really t, so here's my t over here, comma, degrees of freedom, again, n minus 1. That's it. All right, so that's it. Those are the three different forms that we would end up seeing. So these are pretty simple problems. Hopefully you can work through these guys. They're not too hard. All right.